Any question about the last lecture? This is your first lecture? This is lecture number 4. Yes.
Yeah, I signed this course on Sunday.
Wow. So anyway, we already covered about the software, then we cover the design and main types, the logical and the physical. Right now we are covering the logical design. We already covered forms and the reports. So we are starting the interfaces. How to define interface?
It's like a gate to the main program.
Can you off the computer, if you don't mind? It's okay for you. He's using that during the lecture. It's okay, it's okay. Mr. Khalid? Yes, my friend. What's your name?
Basil.
Basil. Yes, Mr. Basil.
Yeah.
Interface.
Interface.
Okay.
So
Gateway.
it's like gateway to communicate between the customer and the program.
Are you sure? Yes. You are agreed? No. Yes. Same. Then you are agreed. Yes, my friend. Interface. There are two definitions. The simpler one, interface is a point of contact between user and the computer. Interface is a point of contact between user and the computer. Like this room is a point of contact between me and you. Yes, between me and you, it's a point of contact about the course, specific course 252. Same thing, interface is a point of contact between user and the computer. The other one is for the system point of view. Interface is a connecting link. A connecting link. You know links?
Yeah.
Like the nodes. Like for network, we have nodes, we have links. Or in the data structure, you have linked list, you have stack, you have queues. Have you used linked list, stack, queue? No. So linked list is there, linkage there. From one node, one point to another point. A connecting link at a shared boundary. A boundary is shared between independent systems. Between independent systems to meet and act on user commands. A connecting link at a shared boundary between independent systems to meet and act on user commands. For example, an example. At system level, where the systems are meeting to each other, they have a shared boundary and they act on user commands. Mr. Khalid, you are feeling very sleepy, huh? Yes, my friend. Darvesh. ATM systems is the best example. All ATM systems are independent. Samba, Al-Raji, NCB, but they have shared boundary. So you can use any ATM machine to transaction purposes, to transfer the money, to transact. To transact. Even some ATM machine you can deposit the money. Deposit or withdraw. You can deposit, you can withdraw. So Al-Raji, you don't have account in Al-Raji, but you can use it.
So the ATM machine, it's a connection between the customers and the bank.
Yeah, but these systems are integrated. They are called one link system. One link from one node to any node, and vice versa. And vice versa. So that is system level interface is there. So how many types of interfaces we have? Interface types. One is from using point of view, user point of view. From the user point of view, we have types. Yeah, we have CLI, we have GUI. Command line and graphical user interface. But at system level, we have also types. We have internal interface and we have external interface. Internal and external. Internal is for the inside the system at application level, like interface between Word and Excel. Interface between Word and Excel. And external for users, like your mobile interface. ATM interface is external for environment, for customers, for users. And then we have subtypes which are called import and export. Import interface and export interface. Anybody knows about the import and the export interface? You know, we have import business, import export business. You know, import and export. Import means you are ordering the items from other countries, and export means you are exporting. You are manufacturing here and you are exporting. Like China is the big exporter, is the largest exporter in the world. Everything is from China. Like 10 to 15 years, everything was from Japan. Like now, everything from made in China, made in China. That time, everything was made in Japan. Exporter. So we have import interface and we have export interface. Import interface, when a component or application needs data from the other application or other component, then we have import interface. When a component or application needs data from other application or from other component, that time an import interface is created. And export, when a component provides the data, provides the service to the other component or other application, then we have export interface. Then we have export interface. Export interface is created. Like ATM. Sometime application is importing, sometime it is exporting. It is acquiring the data from other system, because that customer doesn't belong to this bank. Samba machine will call, system will call to Al-Raji, this is your customer, please provide me his bank account details. That time it is importing, and Al-Raji at the time is exporting. And when Samba customer will go to Al-Raji, vice versa, that time it will import. That time it will import. So a component or application have both interfaces, import and export. So that is the interfaces we have. So we have to design the internal interfaces, we have to design the external interfaces. So form the reports are specifically for external point of view. And interfaces, we are dealing about the internal import and the export interfaces. Clear? The dialogues. Dialogues are like users sometimes have prompt messages or pop-up messages, dialogues from one screen to another screen. You have dialogues. Like sometime you enter the wrong data and system will give you a pop-up message. This is wrong. Or Windows, sometime have dialogues with you that it needs certain driver. It cannot run a missing flash player. Dialogue is there for the user. So user can understand and can install the software. Like yesterday I was using YouTube, it was not working because my hard disk was formatted. So I installed the new Windows, so flash player was missing. So one video I click, doesn't work. Second, doesn't work. Third, I said, what is the problem? Then I didn't notice it was giving me message dialogue. You need to install flash player. So I installed the flash player and the video started running. That was a dialogue. And you miss the dialogue, you will not use the application. You cannot use. Or when you are installing some software, it will give you dialogues. Now you do this, accept the license, the terms and conditions and so on. You have to follow the instructions. That are the dialogues. And then you have the normalization. That is from database point of view. You already covered the normalization? Yes, normalization. What is normalization? Huh? That's Abdullah.
Not to repeat, double part. You need the repeated data to make more
Yes, my friend.
simple the information.
Very good. Yes, Mr. Khalid. So some are saying removing the repetition of data, and my friend is saying simplify the data. Yes, Mr. Khalid. Yes, Mr. Darwish. I want your feedback. No. Yes, Mr. Ryan.
It's a way of speeding the query time by separate the schema in database.
Normalization is a process to convert the complex data into simple and stable data. This is the correct one. Complex data structure into simplified data structure. Make it simple and stable. That means remove the dependencies. You are also correct. So your answer was also correct, but it was missing. Some part was missing. You also miss one thing. Simplify. Don't forget it. Simplify and make it stable. No repetition, no duplication, no dependency, no redundancy. Then we have types of normalization. First normal form, second normal form, third normal form, BCNF, fourth normal form. How many forms we have?
I think
8. 3. 9. 12. Is it auction? 6, 9, 12, 18. Which were the highest? Who said 18? 10. 5. First, second, third, BCNF, fourth and fifth. That's it. BCNF, we don't call it fourth. It's a BCNF. Boy's called normal form. Fourth and fifth. Normally we go up to the 3 normal form. Normally in practice, we don't have time to go for BCNF because fifth is too much simplified. That's difficult to even join. Then you have to denormalize, unnormalize the data. First we are trying to normalize it to make it simple, then it becomes so simple Then we have to unnormalize. So normally industry practice up to the 3NF. It's enough, sufficient. Sufficient, simple, and dependencies are removed. Duplication, no more duplication. Enough. That is the. Any question about this slide? We already covered forms, reports, guidelines, interface specification, physical design. Now you already performed the normalization. Now here I have one question. If you are developing object-oriented system, still you will perform normalization? If you are dealing with the object-oriented system, still you will do the normalization? Hi. No, yeah, no. Yes. It's not acceptable. Mr. Khalid? Yes, Mr. Abdullah? No. Why now?
Because object oriented, there is no repetition.
No, because objects are already normalized. It is only for structured approach. So I want to make it sure that you know that what we will do for the, if you are doing the structured, then you will go for normalization, otherwise no need. Because objects are already normalized. You do only for structured. Now after the normalization, you already have the normalized data. You just create physically the database, schema, tables, fields, primary key, foreign key, and then hierarchical or system structure design. You know hierarchical charts? Hierarchical charts, you don't know. Hierarchical charts. Hierarchy. It's like a tree, yes. Give me example. Any example, Mr. Khalid? Yeah. Like you have president, vice president, dean, vice dean, chairman, yes, the faculty and the administration and so on. So we will go from top to down. Hierarchical approach is also called top to down approach. You go from top to down. Like email system, Hotmail, Yahoo, Gmail, inbox, junk, compose, send messages, trash and so on. Then next, inbox, subfunctions, junk subfunctions, trash, send messages, compose, subfunctions. So you will go from top to down till the most linear level that you cannot further divide the subfunctions. Like in Word, file menu, edit, format, spell checker, thesaurus, so on, help. You have submenus, subfunctions. Open as, save as, open, save as, and so on. Copy, yes. So you will draw hierarchical chart rather than writing. And then you have algorithm designing. How many algorithm designing techniques we have? You know algorithm? Algorithm. You don't know. Algorithm.
Your plan or steps before that.
Yes, step by step solution of the problem. Step by step solution to solve the problem. How many techniques are there under the algorithm designing? What are the main algorithm designing techniques? You already covered the subject for algorithm? Algorithm. Yes, you already covered that. Anybody? We have 5 techniques. We have pseudocode, we have flowchart, we have decision table, we have decision tree, and we have NS diagram. There are 5 techniques are there for the algorithm design. Flowchart is the most widely used technique. Flowchart is the most widely used technique. You already finished the flowcharts? Yes, you already take it. Flowchart. You have standard symbols, again patterns. Again patterns. Standard symbols for input, output, decision, loop, start, finish. Yeah, there are fixed symbols are there. Standard symbols. You cannot change them. Arrow, corrector. The flowchart symbols. There are patterns. You cannot change them. Standard. What are design possibilities? Is our next topic. We have different possibilities. In 251, we have a slide. What are the main design techniques, design possibilities? How many of you already took 251? You are all are took 251 because 251 is the prerequisite for 252. So 251 everybody has taken. Clear. We have algorithm strategy, decomposition, and abstract function. We have in the algorithm we have data driven approach and we have goal driven approach. Anybody knows about the data driven and goal driven approach? Nobody knows. We have forward chaining and we have the backward chaining. Chain. The forward chaining means from one node, like you want to go from Jeddah to New York. What are the connecting flights? What are the connecting flights from one node to another node? One point to another point. You will start from Jeddah and till New York. What are the connectors? So you move from Jeddah towards the New York, one by one, and you will pick one which is the direct from Jeddah to New York, and the backward you start from New York, and then you will check what are the possible connections till the Jeddah. So goal you took first. From the goal you will move back towards the start. And the data driven, you start from your point and then you go towards the goal. So it is called forward data driven approach. And the goal driven, you are starting from the goal and you are moving towards the data. Like you have top down approach and you have bottom up approach. Top down means you are starting from top towards the end. Bottom up approach means you are starting from the bottom towards the start. That is the difference between data and the goal. Forward chaining and the backward chaining. Top up, top down and bottom up. Top down and bottom up approach. So you know your goal. So from the data, from the starting, you are moving towards your goal. Whereas in the goal, you are starting from the goal and you are moving towards the start. What are the possible alternatives? like bottom up. You move from bottom to top. That is the difference between. So in the algorithm, you can design the algorithm based on top down and the bottom up approach. From main functionalities till the simple one. And the top down, from the simple, you are moving towards the main functionalities. You know, top down approach? Divide the main function into sub functions, and you are starting from the top till towards the end. In the bottom up, you are starting from the reverse, from bottom level, and then you are constructing one by one. Like construction of the building. You have first foundation, then first floor, then second floor, then third floor, then fourth floor. The bottom up is, you already have the third floor, the second and the first are dummies. As you develop the actual, remove the dummies, put the actual one. Start first third, put two dummies, two dummy blocks, first floor and the second floor. The ground floor, first floor, second floor, dummy. And you started the third floor. Dummy blocks. Then keep on doing that. But you know, in construction it never works. But in software development it can work. You develop the final module and the remaining are connected from dummies. Keep on developing the actual, removing the dummies. One by one. And application is ready. Okay? Got it? From the software point of view. Okay. Then decomposition of a system, that is the hierarchical stack and the flow chart. So you decompose the system into main sub-functionalities. Divide the main functions into sub-functions. And then you have the abstract functions. You know, we have abstract classes. We have abstract methods. Abstract class. How many type of classes we have? You already covered 2 or 3, yes, Mr. Darvesh? How many types of classes we have? Oh. No, that is modifier. We have abstract classes and we have concrete classes. Abstract classes and concrete classes. Static method. We have static and the instance method. Abstract class and the concrete class. Abstract and concrete. What is the difference between them? The last guy. Yes. What is the firk between abstract class and concrete class? You already passed 202, 203. Yes. Yes, my friend. No, yes.
Abstract take methods and properties from other class and making children from it. I think the abstract.
Yes, yeah.
Class cannot have this or
Yes. Abstract class cannot have objects. It cannot create its instance. Its instances are created in the concrete class. It is just a model. It's just a prototype. It's just a prototype. It doesn't have body. Its method doesn't have body. So we have abstract method, we have stress methods. It's just for prototype, just for model. It's for abstraction. It is for encapsulation, to encapsulate the data and the methods. It's just encapsulate, hides, information hiding. So abstract functions defined in terms of less abstract functions. So you define the abstract and the concrete functions. Abstract methods and the concrete methods. Stress methods. That can have the bodies like inheritance, function overloading, function overriding, and so on. So these are the different levels of the design. Algorithm, decomposing, and separate the abstract functions and the concrete functions. Then design techniques. What are the main design techniques? Anybody? We have structured, we have object-oriented. Structured design and the object-oriented design. In the structured, you have ERD, you have DFDs, you already covered in 250. Data flow diagrams. ERD you cover in the database course. Entity relationship diagrams. Then you have hierarchical charts. We just covered. It's already covered, but I just revise it, repeat it. And then you have the object-oriented design. UML. Yes, unified modeling language. We already covered use case, class, sequence diagram, and the reuse and the reusability, that is under the object-oriented. What is reuse? Reuse. Yes, Mr. Darvesh?
Simple to use.
Use it again. Use it again. Or no answer. Yes, Mr. Khalid? Yes. Simple to use. Anybody? Write once, run anywhere. Write once, run anywhere. This is called reusability. This is called reusability, reuse. Write once, run anywhere. For example, you develop a software 25 years before using C, COBOL, Pascal, Fortran. If in the new system you still need that function, you should be able to call it rather than develop it. Just call it, that function. I use the word calling. How many types of call we have in the methods, in the functions? Why you are sitting so far? It's very difficult for me. Why don't you sit here? Come close to me. Mr. Darvesh? Because even you sit on that chair or before or at the end, I still call you. So it doesn't matter wherever you are sitting. So better sit close to me. Yeah. How many types of call we have? This is my question. Call with parameter or without parameter? Calling functions, calling methods. How many types? Call by value and call by reference. Call by value and call by reference. Mr. Khalid, What is difference between fark between call by value and call by reference? Can you sit straight? Sit straight. Don't put your back. Sit straight. Ah, yes. Call by value. Have you heard about this call by value, call by reference? Have you used this one? Yes, my friend. Have you used? You must have used, but you forgot. Yes.
Call by value,
Normal call. And call by reference? Don't know. Yeah. Anybody? Mr. Yar?
Call by value means call it by name.
Call by value mean when method call another function, one function call another function, calls another function, a copy is provided. A copy is provided, original value is preserved, reserved. We don't allow the user to change the original value. We provide him a copy. So you reserve the original. He will change the copy. In the call by reference, you provide the actual, like pointer. Have you used pointers? By address. By address. So actual copy is provided him, he will change. So normally we don't practice the call by reference. So we allow the user to use the copy. So we keep the original.
You don't want to change the
Yes.
call by reference.
Call mean?
The actual value.
Yes, he will change the actual. So if it is changed, it's changed. You cannot revert it. Roll back. You know, in roll back, in database, we have commit and we have roll back. Once you commit something, you cannot roll back it. So make sure before you commit it, database will ask you, commit? Yes. Done? Cannot revert. Cannot roll back. So, this is something we provide him copy, call by value. So whatever the user want, okay, but actual value is preserved. Once, make sure, then we change by call by reference. Like transaction. Transaction. Done, it is done. It cannot revert. Cannot revert. So it's call by reference. Actual is there. Actual value. We don't allow the copy. Because otherwise, problems will create. Customer will say, no, I did not transact this money. So whenever you transact something, it's done. Database is updated. Yeah, immediately.
So in database we use by reference or
Yes. For such operations, it depends what kind of application. According to application, you will decide you will use call by value or call by reference.
in banks we use call by reference.
Yes. Because transaction is there. You have copy and then he checked his balance, he say, oh, money is there. So he will show you two copies. One without money and one with money. He say, oh, I have money. This is the proof. Then problems will create. He will go to the court and so on. So we cannot take risk. But application to application it varies. So we are talking about the reuse. After 25 years, 30 years, whatever the function you already developed, you should be able to reuse it. You should be able to reuse it. Rather than developing in a new tool, like in Java or in .NET, PHP, C#, ASP.NET, no. Why not? What is the benefit of calling the previous function? Saving time.
Save the effort.
Save money. Time saving, cost saving. Because you already spent lot of money to develop, test, maintain.
And therefore
efforts, resources, everything is are involved. Everything is involved. Just because of a new tool, reinventing the wheel. You cannot reinvent the wheel. It is called reinventing the wheel. Just changing because of a new tool is there. .NET to Java and Java to .NET, just playing. This is not actually programming, this is not software engineering. Software engineering recommends you to reuse the previously developed function, previously tested function. And another reason, it is reliable. We already discussed reliability in the last lecture. What is reliability? We already discussed reliability in the last lecture. Software must have minimum bugs and it must be stable. Because during the 25 years, 30 years, you already tested it so many times. It's maintained. Yeah, it must be stable. It is stable. Because the new has risk. Maybe it will successfully work or it will not. It will not successfully work.